Hello, I'm Sonic. We will learn about linear programming. There are two types of linear programming: Gaussian's elimination method and Cramer's rule. First, we start with Gaussian's elimination method, which comes from Johann Carl Friedrich Gauss, a German mathematician or physicist from 1777 to 1855. Suppose we have two equations. First equation, x plus 4y equals 3. And second equation, 3x minus 4y equals 5. We get a term 4y equally, but comes in opposite sign. So we eliminate 4y. Now we get x plus 3x equals 4x on the left hand side, and 5 plus 3 equals 8 on the right hand side. We get x equals 2. And, on solving them, we get y equals 1 by 4. Or 0.25, by the way. There are three cases of solution. For a unique solution, we have x equals 2, and y equals 0.25, on taking the first equation x plus 4y equals 3. When we put x equals 0, then y equals 3 by 4, or 0.75. The mark 0 and 0.75 lies on the y-axis. Similarly, on the x-axis, we get 3 and 0 as a point. And the second equation, 3x minus 4y equals 5. On the y-axis, putting x equals 0, then we get a point 0 and 1.25. On the x-axis, we get a point 1.66 and 0. Thus, we will join these straight lines for these equations. Next case, if we have an infinitely many solutions. Let us consider the second equation has a multiple of 2 of the first equation, thus we get infinite points. And the third case, no solution. Pick the same equation with different number, say x plus 4y equals 6 instead, similar to first equation. Then we get two parallel lines that does not intersect any common point. Let's see the next section called Cramer's rule. This comes from the Genevan mathematician Gabriel Cramer, 1704 to 1752. In Cramer's rule, taking these same equations from the previous section, we have two variables, x and y. The first equation is given by x plus 4y, which is 1 and 4 in the form of row matrix. And secondly, 3x minus 4y, in the formation of 3 and minus 4, as well. On the right hand side, we have a column matrix, containing 3 and 5. As seen from the topic matrices and determinants. We further solve with one method of this technique. 2 by 2 is a square matrix of A. X and Y is a column matrix of X. And 3 and 5 is a column matrix of B. So we write AX equals B. Just to make sure, we divide by the main matrix. Given the main matrix should not be equal to 0. On cross-multiplying them on the main matrix, we get minus 16. Taking two sub-matrices, A1 and A2. In first sub-matrix, we change the first column. From the given B, solving the first sub-matrix, we get minus 32. Similarly, in the second sub-matrix, by changing the second column from the given B, we get minus 4. To find these variables, x and y, equals submatrix divided by main matrix. We get x equals 2 and y equals 0.25, as seen from the previous section. Similarly, if you have a variable of z, you would try solving these three variables in 3 by 3 matrix and for the elimination method. Now, I would like to give you some interesting question. Amy Rose and I went to Walmart. I bought 3 gold rings and 2 video game CDs costs $3.99, and Amy Rose bought 4 gold rings and 1 video game CD costs $5.69. Formulate this solution and find the cost of each item. Let us take cost of gold ring be x variable, and video game CDs be y variable. You could do this in two ways. On solving them, each cost of gold ring will have $1.08 for x, and each cost of video game CD will have $1.37 for y. You can similarly go to other markets, or shopping malls, or restaurants to buy some foods. like, comment, and subscribe. Thanks for watching.